Several marine mammals, classified as cetaceans, belong to the odontocete family, which includes modern toothed whales. Examples of these include dolphins and porpoises, which are essentially smaller odontocetes, with body lengths ranging from 1.5 to about 9 meters. Dolphins inhabiting inshore or pelagic marine waters belong to the families Delphinidae and Pontoporeidae, while those in riverine systems belong to the families Inidae, Lipotidae, and Platanistidae. It is said that all dolphins are whales and not all whales are dolphins. This holds true since dolphins are classified among the toothed whales, while not all whales have teeth. On the other hand, porpoises belong to the family Phocoenidae and primarily inhabit inshore and pelagic waters. Just like dolphins, porpoises fall under the umbrella of the toothed whales. Interestingly, these two creatures have the same basic body shape, which can either be a streamlined spindle or fusiform. This shape allows them to navigate easily through the dense water medium. On top of their head is a single blowhole, which they use for respiration. They also possess numerous teeth that are all alike in structure, a phenomenon called homodont. Most of these creatures have a fibrous dorsal fin located near the middle of their back that acts as a radiator to cool their reproductive organs, acts as a weapon, and acts as a swimming stabilizer. They also exhibit countershading with a darker dorsum and lighter ventrum, a feature that helps them camouflage during hunting and avoid predators. The teeth and jaws of these two sea mammals are designed to capture prey rather than chewing it. Generally, dolphin species exhibit considerable variation in terms of length and the demarcation of their projecting beaks, the shape, size, and number of their teeth, and the presence or absence of a dorsal fin. The size of the dolphin's beak and the shape of their mouth are normally determined by the teeth. For instance, Risso's dolphins lack a conspicuous beak and have 10 teeth located on their lower jaw, which are meant for grasping soft-bodied sea animals such as squids. Also, spinner dolphins have more than 200 teeth that are meant for catching small fish and other invertebrates in their vicinity. Female dolphins usually possess both a genital and an anal opening within a single ventral groove, accompanied by nipples situated in mammary slits on either side of the genital opening. In contrast, males typically have a genital opening in a ventral groove anterior to a separate groove for the anus. Moreover, the color patterns of dolphins may range from gray, brown, white, black, orange, or pink. Normally, the color patterns of dolphins found in oceanic water are more complex compared to those living in murky waters of estuaries or rivers. Surprisingly, the largest of the dolphins is the killer whale, also known as the orca. On the other hand, porpoises are quite smaller, and the adult porpoise's body length ranges can be approximately 2.5 meters or less. Something about these creatures is their small brain cases that make them retain some of the childish behavior and features even as adults, a condition called pedomorphosis. Porpoise teeth are either spatulate or spade-shaped, and their dorsal fin is typically low and triangular. Their stocky and robust features, including relatively small appendages, help them retain heat, thus surviving in cold waters. The eyes of porpoises tend to be surrounded by a darker pigmentation, a trait that is much pronounced in the spectacled porpoise. And how do these sea creatures communicate? Both dolphins and porpoises take advantage of the water density in which they live, which acts as a medium for sound transmission. Since they cannot see much farther than 30 meters in clear waters, their ears have been modified to receive a wide range of underwater vibrations. Therefore, they normally produce echolocation clicks varying in frequency. The low-frequency clicks, referred to as orientation clicks, help these sea creatures have a vivid idea of their surroundings, while the high-frequency clicks, known as discrimination clicks, help these animals have a clear picture of a particular object. In simple terms, echolocation is the process that enables these sea creatures to utilize sound waves to detect, recognize, and distinguish other creatures, things, and objects from a distance. This particular sound and ecosystem help them in various ways, like navigating through the water, finding prey in murky waters, and also maintaining a strong and connected social group bond. However, pure tone whistles are normally associated with dolphins, a trait that is lacking in porpoises. For instance, the bottlenose dolphin is known for producing signature whistles that are uniquely and specifically structured, helping each dolphin claim their identity and get recognized by their relatives and kin. Another way dolphins communicate is through the production of burst pulse sounds or squawks, which are commonly utilized in their social settings. And how are dolphins able to produce these clicks? The larynx of dolphins normally lacks vocal cords and instead has a ring of muscles that act as a valve. This enables them to control airflow through the larynx. Once air under pressure circulates through their nasal passages, clicks and other sounds are produced. These sounds are then directed towards objects in front of them and not below. As these sounds travel through the water and encounter an object, they are reflected as echoes, which are then picked up by sensitive areas in the lower jaw that send vibrations to the inner ear. The animal's brain then processes the information, such as the direction from which the sound is coming, the amplitude, the change in frequency, and the elapsed time before the emitted sound returns. With this information, the dolphin's brain is able to produce a mental image of the target object, including its size, shape, distance, texture, and density. But how is this possible? Frequency changes of the returning sounds help determine the shape and size of the object, while the amplitude and time factors help determine the distance. The direction of the sound helps them establish the correct bearing of the object. Even though dolphins and porpoises spend most of their time underwater, their behavior and social organization are unique. For instance, dolphins enjoy riding the pressure waves created by water vessels, and they accompany this with their unique acrobatic jumps. Their jumps can either be multi-revolution spins, as seen in spinner dolphins, or high, arcing jumps, as observed in pantropical spotted dolphins. Porpoises rarely perform these jumps. The head movements of dolphins from side to side and up and down allow them to scan a broad path ahead, and these motions become fast and jerky when their target objects are smaller in size, such as small fish. As we conclude, most dolphin species are social animals and can be spotted in a group of a few or many individuals. However, porpoises and river dolphins are more introverted and prefer to enjoy their solitary moments. Sometimes they can be seen with a very small group, which is common among mothering individuals. I hope you enjoyed this video. If you would like to see more similar content, please check out my other videos and subscribe to enjoy more of this kind. Thank you for watching, and see you in the next one.